At ConsuLab, we design innovative training solutions for automotive and heavy vehicle programs. Today, we're excited to introduce an essential tool for teaching driveshaft dynamics, the EM-200-28 Driveshaft Working Angle Trainer. This trainer helps instructors demonstrate complex driveshaft phenomenon in real time, showing students the importance of proper phasing of U-joints and the adjustment of working angles. With this hands-on tool, students can observe how driveshaft behavior changes with different angles and phases. We use universal joints on cars, trucks, and heavy equipment to transfer mechanical power between two shafts when their axes are not aligned. For example, between the output of the transmission and a differential. However, a universal joint is not a constant velocity joint on its own. If we look at one universal joint, we can see that it is composed of the input yoke, the cross in between, and the output yoke. The speed of the input yoke is constant, but when the two yokes are at an angle, we can see that the planes of the input and output yoke rotation are not the same, and this causes the cross to rotate. As the input yoke turns, the cross rotates to its maximum angle, during which time the output shaft accelerates and spins faster than the input shaft. Then the opposite happens. The cross rotates in the opposite direction, and the output shaft turns slower than the input shaft. Now remember, overall, the average speeds must stay the same. This just means that a single universal joint is jerky in its movement. The magic is we can simply add a second universal joint to the system to completely balance out all this acceleration and deceleration. So let's make this simple for your students. Let's start with the basics. On a normal vehicle, the engineers have designed everything properly. The U-joints are aligned, in phase, cancel out, and are set at the same angle. This means the driveshaft achieves a steady, balanced rotation. Here, as I turn on the trainer, you'll see how the acceleration and deceleration forces are naturally cancelled out. Now, let's adjust one of the U-joints out of phase. With the U-joints out of phase, or at differing angles, you'll notice a very large increase in the acceleration and the deceleration at each rotation. What is fascinating is that the speed is still the same. And if we drop this back into a straight line, there are no accelerations or decelerations. It's magic. Now, having the U-joints out of phase is pretty hard to do. A more common occurrence is an adjustment of the working angles. This normally happens when someone lowers or raises their vehicle, effectively changing the working angles. If any of your students have a lifted Jeep, you can use it for this demo. When a lift kit is installed, the angles often change and remain uncorrected. Let's change the angle here. Now what happens is that the accelerations and decelerations are not cancelled out, not entirely at least. We end up with that vibration. With the EM-200-28 trainer, you can also explore other driveshaft conditions. By adjusting the height, angle, and phases, instructors can create scenarios that would demonstrate real-world conditions and troubleshooting, making it easier for students to grasp why driveshaft alignment is crucial for smooth vehicle operation. Now you might think and worry that a rotating shaft out here in the open is very dangerous, and you're right. But safety is always top of mind with ConsuLab products. If a student were to accidentally restrict the driveshaft, or if any object obstructs it, clothing, hair, or anything, the torque is limited to prevent injury. This ensures students can safely observe driveshaft operation. The EM-200-28 Driveshaft Working Angle Trainer makes it easy to teach complex mechanical concepts safely and effectively. To learn more about our products, please visit ConsuLab.com or reach out to your sales representative for a quote. And don't forget to subscribe to our YouTube channel for more product highlights and instructional content. Thanks for watching.